viewers, and welcome to my YouTube channel, Maths with Adevik. I'm Victor Adewale Adeleke. Here, our major focus is to teach you mathematics from the onset even of tertiary institution. If you are yet to subscribe to my YouTube channel, do well to subscribe, like, and share this video. It is very important so that whenever I post extra materials like this, you will always get notified. Okay, here we want to provide proper solution to this problem. Unlike the one I recently did, the one I did recently, I did put the power of 3 and I solved it. It was actually a meme just to make you laugh. Many persons will solve that question in a very sharp and smart way. They will just take x to the power of 3 and separate, because there was no power of 3, mind you, so there was no power of 3, so you could just separate this x to the power of 3 to each of them and integrate individually, separatively, and you get your answer. But in this case, we have a power of 3, so that method will not work. That procedure or that process will not work. Yeah, so in that video I solved the same question but not to the power of 3, and I used the same two different method of approach to provide solution to it. But let's see what we can do with this. Let's see what we can do. This is the power of 3 here, so this is going to be a whole lot of difference. There's going to be a whole lot of difference. So what do we do? Let's first of all use, I'm teaching about the quotient rule again, so let's first of all use the product rule. This is the product rule now. This is the quotient rule. So let's use the product rule first to solve this. Now, if you have not watched my video when I talked about, I was teaching about how to use the product rule, so how to use the chain rule, because this is a function of a function. You can see this is x squared plus 2, a function of another function, the power of 3. So we want to use if you not watch that video, go back and check on that video, learn how to take the derivative of a function of a function. So let's do that. Let's quickly just do that. So if you want to solve this, let's call that du dx. So du dx will certainly be equals to 6x x squared plus 2 all to the power of 2. Yes, so that's if you have mastered the chain rule, which is the function of a function, very well, you understand how to just with your eye, by sight or by inspection, just tell the answers of how their derivatives will look like, the function of a function particularly. So let's see what we can do. We have gotten the du dx. Now what about, we already know that v is x to the power of minus 3. So mind you, we're using product rule, so we have to use this, not this. So this is it. So the v dx here, the v dx will be equals to the negative 3 to the power of negative 4. So let's see how we can quickly use the product rule to provide solution to this before we use the quotient rule. So to do that, just replace, we have gotten dv dx, we have gotten du dx. So let's go. So dy dx will certainly become v. What is the value of v? We have the x to the power of negative 3, v du dx, which is what, 6x all squared to, you know what I'm talking about, then minus or plus, sorry, plus, but because of this negative sign, yes, certainly is going to, we are going to have a minus sign. So u, what is the u? We have your x squared plus 2 to the power of 3, then 3x to the power of negative 4. So from here, we are going to work with pure factorization. You have to understand factorization very well. So in this case here, we are going to bring out 3x to the power of negative 3. Okay, this one I'm bringing out 3 because 6 is here, so it has a factor of 3, so we brought that 3 out. So what are we going to have? We're also going to bring out this out. We're going to have 3x squared plus 2. Yes, so something like this. So what do we do from here? We are going to write them out in such a way that when this one expands the bracket, it's going to be simplified to become like this. So you can see we have all of this outside, but we don't have 2, so we can put your square here. So we have your 2 what? X. Why 2x? Because when 6, this is 6 here, so when 3 multiplies 2, we have 6. We have 6. So you see your x cubed, your x to the power of negative 3 came out, then your x remains here. So from here, we just put our negative sign. Then what is already here, we brought out to the power of 2, this same function to the power of 2. So since we have to the power of 3 here, which means we still have 1 left here, x squared plus 2. Then what else? Then we have a negative x to the negative 1. Yeah. So what does this mean? Everything here means over x. Yeah, this is what it means. So understanding your algebra. So when you simplify this function, you are going to get something like this multiplies this. You have 2x squared minus x squared. The minus affect this. You have minus 2 all divided by x. All divided by x. Then you have what? You have x squared plus 2 all squared. Then you have 3x to the power of negative 3. So what do we do here? This x removes 1 from this. And don't forget, this is minus 3. So the law of indices, x to the negative 3 divided by x. So you have minus 3 minus 1 because this is to the power of 1. So what do we have finally? You have 3x minus 4. Then you have x squared plus 2, x squared plus 2 all squared. Then 2x squared minus x squared, you have just x squared minus 2. Just trying to maximize space. So that's your final answer. So this will be our dy dx. So that was dy dx. 3x to the negative 4, then x squared plus 2 squared. Then we have x squared minus 2. So this is the solution to that. But let's see how we can use the same. Let's see how we can use the quotient rule to provide solution to this same kind of question. So the quotient rule, we already have du dx is this, so we're still going to use du dx here. But mind you, if you notice the product rule, we took this as a product, so it becomes a negative 3. So you are not going to use you cannot use the same dv dx. No way. You can only use the same du dx, but we cannot use the same dv dx. So du dx remains the same, but dv dx has to be different. So the du dx here, dv dx, sorry, is going to be, we are going to take the derivative of x cubed. So dv dx is going to be 3x squared. Yeah, so when you take the derivative of x cubed, you have 3x squared, because the 3, you know what, if you go back, if you are not familiar with that trick, go to my playlist titled, that's in case you are just stumbling into this video and you've not been following up, just go back to my channel. You know how to go back to my channel. When you get there, you look for the playlist calculus, because I have other playlists on trigonometry, on geometry and all that. So under calculus particularly, so when you go there, you look for where I talked about techniques in differentiation. There's a topic like that, technique in differentiation. Then when you get that, you study that and you understand what to do, so you know how we came about this. So once you've noted that, the next thing to do is to plug in the value of v du dx minus u dv dx, then all divided by v square. What is the v square now? It's x to the power of 3. So let's see what we can do to get that. So to get that, we just say equals to what? What is our v? Okay, so we're starting here, equals to, so we are looking for the derivative of what? Of this function. So what do we do? What is v? V is the same as x squared plus 2 all to the power of 3 times is producing du dx. What's du dx? 6x x squared plus what? 2 to the power of 2. So this is what we got. Yes, to the power of 2. So once you've gotten that, that's v. No way, no way, no way. So mind you, that was an error. What was v? Let's not get it twisted. V, this is uv. This is the quotient arrangement. So uv. So it's going to be v first, which is x cubed. Then producing with 6x x squared plus 2 to the power of what? 2. Yes. Then minus, this is minus now, unlike that one that was plus but was affected because of the negative sign from the derivative of the x to the power of negative 3. So that one is different. Let's forget about that. So this one has a minus sign. The formula has a minus sign. So we put your minus. What is the u? The u is x squared plus 2 to the power of 3. X squared plus 2 to the power of what? Of 3. Then what is our dv dx? Our dv dx, we found out, is what? 3x squared. Now don't forget, this is all divided by what? V squared, which is x to the power of 3 and 2, because v is what? Is x to the power of 3. So when you square it, when you square to the power of 3, you are going to get 2 times 3, which is what? 6. So what do we do now? Let's think of how we can factorize. We have 3 here, we have 3 here, we have x squared, we have x squared here, we have x plus 2 x squared plus 2 squared, we have another x squared plus 2 squared here. So what do we do? Let's factor that out. So by doing that, you have something like this. You have 3x squared. Yes, 3x squared. Then you have x squared plus 2. You must understand factorization. Very, very important. Maybe I'll create a class on that. Factorization, though, is a basic mathematics, but I think it's very important, very, very important to understanding mathematics, because every branch of mathematics adds up to become a final foundation or a final building, an edifice at last. So what do we have here? We have 3x squared, then we have x squared plus 2. So we have to the power of 2. Yes. So what else do we have? We have 3x squared here. So we are going to put 2 here so that when 3 goes back, it becomes 6. Multiplying these two together, we have quart, that's x to the power of 4. So here we have to put 2x to the power of 2 here to make everything okay. Yes. Then everything is balanced. Then you minus. Then what else? We've brought out 3x squared out. We brought this one out. So we need one more left here. So we have x squared plus 2. So let's just say the minus goes into the brackets and this becomes minus all divided by x to the power of 6. So what happens here? This remove this, then we have x to the power of 4 left here. So I don't want to waste space. So since we've noted this, this x to the power of 2 is divided by x to the power of 6. So what do? We can just clean everything here and put just x to the power of 4 here, and we are still okay. Very much okay. So from here, you know that x to the power of 4, because it's a denominator, it can be represented as 1 over x to the power of 4, then 3, then x squared plus 2 squared. Then what do we have? 2x squared minus x squared. We have x squared, then minus 2. Then what do you have? What does this mean according to the law of indices? It simply means x to the power of negative 4 times 3, which is the same as what? 3x to the negative 4, then what? X squared plus 2 squared, then x squared minus 2. This is the derivative. Still the same as what? You can check, you can compare and contrast. Actually very, very the same. So this is how it works. Very, very perfect. Mathematics always perfect in all its spheres. So the reason behind this is that sometimes the reason behind this quotient rule is because sometimes some questions are even more complex than this. You can have a square root at the denominator. Sometimes you have a cube root or a quartic root at the denominator. That will be a very, very massive problem. So you just need to quickly use the quotient rule and get the answer immediately. Because this question, you see, that a little bit lengthy the same. Which anyone to your preference, whatever method you want to apply, the answer falls out as a pack of card. If you are yet to subscribe to my YouTube channel, do well to subscribe, like, and share.